Hello and welcome to my stream. Today we are going to talk about the arrays once again, and we are going to tackle some issues together and solve some CS50 exercises. So let's start with one addition to the previous task that we solved in the previous session. It's called Scrabble. And we made a slight mistake when we blindly assumed that this word is something that it's convertible to character that it's alphanumeric, because otherwise we might end up with the index that it's, for example, -32 or something like that. And we were lucky because it was evaluated to 0. But it could be anything because we are reading from the memory that we shouldn't, and it's not allowed to do so in general. So let's start with compiling this program. So let's run make command and let's run it. So first of all, we have to choose the word for player 1. It might be hello with the exclamation mark. And the second one, it would be the same word, but without exclamation mark. It looks like it's tie, but here you can clearly see that we are ending up with the index below 0, which is not something that we should do, and it's basically dangerous to do so because we are reading from the memory that it's blocked for us. We shouldn't do that. Basically never. Okay, so the rules are simple. We have to fix that. We have to assure that we are going to read only alphanumeric chars. So in order to do that, we have to use either function that was prepared by the guys who wrote C-type, or we could write our own version. This time I will go with the first option. So I'm going to use the built-in function called isAlpha. And we can quickly do the printf statement, so we will be able to debug it on the fly. Let's write this expression. So we have isAlpha, word at I position, and let's do the quick check. So we want to actually print the non-alpha numerics in our case, just to make sure that exclamation mark is one of the examples of non-alphanumeric. So we have two upper, or rather it is not alphanumeric, and we want to print char, so that's why we have to use %c here. Let's compile this program once again. Let's clear it. Then we will run make once again. Okay. And let me run this program once again. So we have player 1, hello, player 2 hello without exclamation mark, and we can see here that the exclamation mark is not an alphanumeric, so we can check against it, and we will be sure that if we do this calculation here, so if we subtract uppercase version from the HR, we will always end up within this range. So let's do that. So we want to remove all those debug statements and make sure that we are calculating the scores only when word at I position is alphanumeric. So in our case, it would be if is alpha word at I, then do this. Otherwise, we don't want to do anything. So now we should get the proper results like we received previously, but now our code is bulletproof, or more bulletproof than before. So let's clear the terminal once again, and let's make it, and now let's run it. So we have hello, hello, and now it's a tie, but we are not reading from dangerous position in the memory, from the area that we are not allowed to read the memory from. And that's basically it about the Scrabble problem. So as a next exercise, we will tackle readability. And I'm going to remove all this code because I previously submitted this code before starting this series. That's why it's there, but don't worry, we are going to write it from the scratch together. So let's read the introduction first. So we have readability. And what we want to achieve here is to implement a program that calculates the approximate grade level needed to comprehend some text. So for example, if let's pause here. So for example, if the text is congratulations, today is your day, you are off to great places, you are off and away, the program calculates that the person is probably or has a grade 3, but in the next case is a text from Harry Potter, I think, and it was evaluated as a grade 5. So it's much more complex, and we are going to build this program from scratch. So in order to achieve that, we have to calculate this Kalman Liao index. I hope that I pronounced it in a right way, but sorry, don't blame me. I will try to improve all the time. So let's calculate index first. In order to calculate index, we need to calculate letter L, which is the average number of letters per 100 words in the text, and S is the average number of sentences per 100 words in the text. So I will use ExcelDraw tool, which is excellent for our use case because we can write some notes here, and also I can explain some things on the fly. So we know that L is the average number of letters per 100 words, and we know that S is the average number of sentences per 100 words in the text. So the main question right now is, how are we going to calculate number of words? So that's the first question. How are we supposed to calculate number of words in the text? How are we going to calculate number of words in the text? That's the first thing, and the answer is given in this video. So let's open it.
Let's take a look at readability.
Let's
Tend to
skip
mean that
some of the content here.
For beginning example, we can, and we want to find out how many.
So in order to calculate letters, which is the next thing that we are going to do, we will just count letters one by one without counting spaces.
At first, letters is checking count. We don't want to count that in our.
As you can see here, he explicitly said that we didn't want to count spaces in our total count of letters. Let's go to this definition. So we have words definition, and we can count it by just counting any characters separated by a space. So we have a sequence of characters, we have a space, next sequence of characters, and those would be counted as 2 words. So here in this video,
with a space in between words, and there's a space after each word, but there's no space after the last word in the string. You can assume that the string we provide to you won't start or end with a space. So even though there are 4 spaces inside of this string, there are actually 5 words in the string. And in general, we can take the number of spaces and add 1 to it to figure out how many words there are inside of any given piece of text. After we figured out how many words there are, the final step in terms of what we need to count up is counting up the number of sentences that appear in that text as well. And again,
so the next task would be to count number of sentences in the text, and we can take into account any period, exclamation point, or question mark. Those characters would indicate that it's a sentence.
Text. Congratulations, exclamation point, today is your day, period, denote the end of a find here into the Coleman layout and subtracting what that reading level. If it turns out that your output would have.
So let's start from the words definition. So we know that the number of words in the text is number of spaces plus 1. So let's add this node to our nodes. So we are going to calculate it by just calculating number of spaces in the text plus 1. Or it's per sentence. Let me check. Once again.
You can assume that the string, we have 5 words in the string. And in general, we can take the number of spaces and add 1 to it to figure out how many words there are inside of any given piece of text.
So let's assume that it's correct. But I think it's per sentence. I need to check that. We can always check for some help here in this area. Okay. So first of all, we have to include cs50.h like here. We need string .h as well, and we need ctype.h later on. But let's first focus on this program here. So we have a int main void, which is a standard main function, and we need to ask for text first. Let me cd or change directory to readability space. Actually, I need to do cd. Yeah, there we go. And let's ask the user for the text. So in order to print something, we need to include standard IO. As well, otherwise printf won't work. So let's try just printing hello and welcome on the stream. Let's make this program. Add, and let's run it. So it's readability. Hello and welcome on the stream. Readability. Okay, we are missing a new line character, so it would be better formatting. Okay. Let's clear it and let's make it bigger. let's make it a bit bigger. Well, actually, it's a bit too much, I think. Okay, so let's make it once again, and let's run it. Okay, there we go. So now we can use our string type, and we can use text and get string method from CS50. And I think the input is just text. Yeah, so we need to run the program, and it should prompt that text double colon. Okay. There we go. Okay, let's do this bit by bit. Okay, great. So we know how to get the input from the user. Now we have to calculate words. So let's assume that it's correct formula. So we want to calculate number of spaces in the text and add 1 to the result. But we want to make this program a bit smarter. So we can do this in many different ways, but one of them it would be to calculate only number of spaces in one run, and during the second run we could calculate number of sentences and so on, but we also can do that in one run. But I think it would be much simpler to calculate it firstly in more runs and then improve our code base and optimize it a bit. Okay, so let's write function called calculate words, or rather words number, and it will take a string text as a variable, and we are going to write a for loop we will run over the all text and just calculate number of spaces, and that's it. We can also check out the documentation of handy functions of C type, for example. Yes, we have a space, for example. So in our case, I think we should check directly for the space. Maybe this one would work. Maybe there is something a bit different, but I cannot see what we could use here. Is space. Is it for long or local or what? is blank. It's a bit better. I think we can just check for the ASCII value of space, and that's it. And just check against this value. So let's check it. I found images to be more convenient than other websites. Okay, there we go. Oh, actually, it's not that helpful, or it's not helpful at all. Let's try something else then. Okay, I think this would work. Yeah, so space is 32. It's 32. Okay. So we can actually make our own function is space only. Let's go that way, and it will take a char C as an input or as a parameter, and it will check whether C is equal to 32 or the int. Well, let's actually check how should we compare strings, chars, and numbers in C. I think we can do a quick test ourselves instead. So let's check it. Let's make sure that this prototype is here. Okay, and let's check the first character of the text variable. So in our case, it would be the space only text at position 0. If it's a space, then print some space there. Nice. Okay, so in order to test it, we need to make our program. Oh, it's not working. Is space. Oh, I made a typo. It happens. It's normal. Okay, and we can comment it out just for a moment. Oh, actually, let's comment everything and make sure that we have only one command. So after doing uncomment, then we can just tap one shortcut, one button, and that's it. Okay, so let's make it. I forgot about the semicolon there. Let's make it once again. Okay, there we go. And now we can clear it once again, and let's make sure that our is space only handy function. It's working. So let's run it first. Let's run it first and let's type space. Okay, and let's hit enter. Okay. So our logic is correct. Our program caught the space properly. So now we can use this utility function in our loop. So let's uncomment this code. And let's make this full for loop once and for all. So it's string len text. And for this utility, we need to include string, I believe. And let's make sure that we are not wasting our memory. So it's text length, just this text length. Okay, and let's make sure that we are incrementing our counter here. Great, so now we can count spaces by checking if our character at I position is space and just add 1 to it. So if it's space only, then we can add it to our sum or number or spaces number, or rather it's words number actually. So it would be initially 0, and now we are going to increment words number by 1, and finally after everything we want to increase it once again, and then return words number value. We want to check text at I position. Okay. So let's go back to the walkthrough here, and I think we can just write it down in our notes. So in our case, it would be an example right here. I'm not used to this tool that much, sorry for that. Actually, it's first time that I'm using this tool, but I've seen that many people have been using this tool, and it's really powerful and really simple to use. So I gave it a spin. Okay. So let's make sure that we didn't mess up this example. So it's as years went by there. As years went by there. This sentence should
After each
result with 5 words as specified here. What's going on with this translation? What the heck? Please, I don't want to use it. Oh my god. Okay, thank you.
But we shouldn't in between string. Each word.
So I think here he's showing that
But there's no space after the last word in the string. You can assume that the string we
the
provide to you
result should be
won't
5.
start
The result should be 5 in our case.
or end with a space. So even though there are 4 spaces inside of this string, there are actually 5 words in the string.
Yeah, so 5 words is our goal. Let's check whether our program is working correctly. So let's assign it to words number. And let's use our calculate words number function. Let's pass the text and let's make sure that the prototype is up here. And we can use this function. And let's print the result here. So number of words is person I and words number here. Okay, let's make sure that I didn't mess up anything. So let's clear it, let's make it, and let's try this program. And let's copy and paste this bit of text here. And number of words is 5. So it's correct. Let's make it more explicit and more pretty in terms of formatting, because I messed up new line here. So let me fix it. Okay, now we can try it once again. Now there we go. We have number of words 5. Okay, so that's the first thing that we have to do. Next question is, how are we going to calculate number of sentences in the text? And the answer we've already seen here. Any period, exclamation point, or question mark indicate a sentence. So for example,
Congratulations, exclamation point, today is your day, period. In this particular string, you'll notice that there are 2 punctuation marks that denote the end of a sentence. We have 1 exclamation point and 1 period. And so as a result, we could conclude that based on this particular string, we're able to find 2 sentences inside of that string.
so we can calculate number of sentences based on the any period, exclamation point, or question mark. So let's make the other function for that. Why not? Calculate sentences number. Let's do the same thing. Let's remove this variable and replace it with sentences number. So instead of in is space only, we want to call the other function, which we could name like is sentence is sentence end, or just, yeah, I think it's sentence end would be a good one. So just to make sure that it's more readable, we can split it by adding some underscores here. And let's make sure that prototype is matching our underscore. New convention, and here as well. Okay, so in order to check if it's sentence end, we have to make sure that our char is either exclamation point, exclamation mark, or it's question mark, or it's just a period. Let's copy and paste this here. So we are going to basically do the same thing, but the only thing that it's different is the predicate here. So we want to check a different thing, and during the program improvement or doing or making this program more efficient, we can simplify this code massively, but that is the thing that we are going to tackle after just making sure that everything is working. So we will have at least a working solution, maybe not the most efficient one, but good enough. There's a sentence like done is better than perfection, you know, so that's something that it's really, really important. When you want to deliver something, it doesn't have to be perfect, but it has to work. Okay. So we have sentences number. Here we have text length. Okay, and now we have this function. So we have to make sure that this prototype is also declared here. And we want to calculate sentences number by just calling the proper function. And we don't want to increment sentences number like we did for words number. So that's why I had to remove it. So let's calculate sentences number text as a parameter. And now we can do the same debug message, almost the same because we want to check number of sentences. And here we also have to replace this variable with sentences number one. Okay. And let's use the example from here. So it's congratulations, today is your day. So let's make sure that this example is also here. So let's make sure that we have example. It was congratulations. Today is your day. Is that right? Yes, it is. Okay. So let's test it out. First of all, we have to make our program, of course, semicolon, something different. Oh, I declared this prototype, but I forgot to declare our calculate sentences number function prototype. So let's fix it. And now we can make the program. Let's clear the terminal and let's run it. Oh, I have to copy the example once again because I copied prototype instead. Okay, there we go. Let's make sure that we have this period sign here. So it's day, period. Number of sentences is 2, so that's good. It's according to the example, so that's good. And now we have to calculate letters. So that's the last thing. Let's write it down. Number of letters in the text. Okay. So let's make sure that we have an example here, and let's
creating a variable, I'll call it letters, that's going to keep track of string sentences in uppercase.
Let's watch the video once again because we will have letters calculation presented here,
which is calculated as follows: 100 words in this text, and S represents the average number of sentences per 100 words in this text. So in order to determine the readability of a particular text, what we need to do is calculate the number of letters, words, and sentences in that text, and then use the Coleman-Liao index formula to figure out what grade level might be most appropriate. So let's take a look at each of.
Okay, so I think the solution is rather simple. So we need to calculate this formula. Let's just copy it over here. It's in the result index. Let's call it that way. So our L, it would be sentences number divided by 100, and S, it would be divided words number divided by or no, actually not. This L is actually correct, right? No. It's per 100 words per text. Okay. So we need to calculate number of letters first. Okay, so let's do the same thing here, almost the same thing. So it's calculate letters number. And we want to calculate letters number. So I think in our case it would be only letters. We would only calculate letters, but without any exclamation marks and so on. Let me check.
Some text as a letters be 0. So notice we shouldn't until we end for taking a character and assessing whether or not it is in fact a letter. Once we've figured out how many letters declared in a file called ctype.h, that might help you for taking a character and assessing whether or not it is.
So let's take a look on the manual pages side, and maybe we'll find something here. Is letter. I think is alpha would be helpful once again. So let's use it in our copy, and let's make sure that this has the proper name. So it would be calculate letters number. We need to assign letters number instead, and we want to use is alpha here, and also increment letters number and return letters number. Okay. And in order to use our isAlpha utility function, we need to include ctype.h header file and make sure that our prototype is living here, so we can use it and just make sure that our logic is correct. So it's letters number, calculate letters number, text, and we have letters number, so we can printf number of letters, also %i, new line character, gosh, letters number. Okay, and let's check it on this example that they've given us. So nearly 400 years. Let's write down, so it's nearly 400 years for nearly 400 years. Okay, so let's copy this and let's make our program. Oh, I can already see that I forgot about the semicolon, so let's make it. Okay, so let's comment this because we are not using it. Oh, I messed up something. What's going on? Oh, I forgot printf. It's print. Okay, so now we can clear it and make sure that our calculate letters number is working correctly. Let's copy the example here, and we have number of letters calculated to 22, which is correct according to the example. But we need to calculate
that C has some help
average
with the text. The next
right now. So
X corresponds to the reading level of that text. But we do want to set a minimum and a maximum here. If it turns out that your output would have been less than 1, your program should just output before grade 1. And if the output is 16 or higher, then your program should output grade 16 plus. But anyway.
okay, so if our output is less than 1, we should output before grade 1, and if our output is 16 or higher, we should print grade 16 plus. So we have some examples here. I think this one would be really helpful because it's grade 2. So let's make sure that it's somewhere near us. Okay, so we need to calculate L. What is L then? L is the average number of letters per 100 words in the text. And S is the average number of sentences per 100 words in the text. How are we going to calculate average number of letters per 100 words? Let me think for a moment. So where is the average number of letters per 100 words? So if we calculate the total number of letters in the text, and we calculate number of words in the text, I think we can divide it somehow. Let me check one thing. L is the average number of letters per 100 words in the text. Okay, so in order to calculate average number per 100, we need to make sure that we have at least the number that we have to multiply our L by. Not sure. Number of hundreds, words in hundreds. So it would be words number per 100. So we need to make sure that we will multiply by this number. So number of words in hundreds. And we will also use number of letters per 100. So our letters number should be divided by divided by 100, pardon. And then multiplied by number of words in hundreds. That's my assumption. Not sure if it's going to work, to be fair, but we will see. And the same thing we need to do with sentences. Number, we need to divide them by 100. 100 words, text, and multiply this number by number of words in hundreds. And yeah, let's check the answer. I don't think it's going to be int, but we will see. Result index. Okay, so that's our sentence, or rather text. Okay, so let's make this and let's run it and copy and paste our text. And our answer is minus 15. Interesting. Let's make the program once again and run it. It's minus 15. Probably we need to convert it to float. In order to get some meaningful result. But not sure. We will see. Okay, it didn't work. So we need to clear it, and let's use some Google for this one. So if the abstract contains 5 sentences, let me increase the font size a bit. So if the abstract contains 5 sentences and 119 words and 639 letters or digits, L is this and S is calculated as 4.2 because okay, so it's number of letters divided by words and then multiply it by 100. Okay, so I think I didn't understand it at the first glance, but let's make sure that we will do it properly this time. So letters number divided by, we need to cast it to float for sure. And this also should be float, not int. There we go. So we have letters number divided by words number. And we want to cast it to float for sure. Okay, and then we want to multiply this result by 100. And we want to do the same thing here. So float sentences number, float words number, multiplied by 100. And now we should get a better result, I think. Sentences, I made a typo. There we go. Let's copy this, let's paste it, and we have answer 2. Okay, so that worked. Now let's check some other examples like this one. Okay, so the answer is 4, which is not correct. Because we should round our score. So we need to round. So probably we have some math utility function as well here. Yep. And we need to find round in math.h. Round to nearest integer. But we want to use an int variant. It just round, which takes float and returns float as well. So probably this, no, this returns double. So in our case, we can use either of these. This would be long. Okay, so let's use round and just cast it to the int, and that's it. Okay, so our result index would be round. Would be result of the round function. that will round the number to the nearest integer. Okay. So let's use it here. I mean, in order to use our round function, we need to include math.h, and this is the manual for this library. So we have ctype.h, but also we can type here math.h, and we will get a whole bunch of available functions and that someone wrote for us. Okay, so let's make our program. I always forgot to include those semicolons. Clear. Make readability. And let's run the program. So we have a text here. And we had text somewhere here. There we go. Okay, so we have our text. Let's copy and paste it. And now it's correct. Okay, so let's use a bit more complex example. Let's run the program again. Let's copy and paste it. So the answer is 10. According to the example, it's correct. Okay, so now we want to tackle a really complex one. So our answer is 18, but it should be rather before grade 1 or grade 16 plus. So this probably will be a 0 or minus 9. So we want to do a quick if statement here. So if result index is less than less than 1, then we want to output before grade 1. In other case, if result index is greater than 16, I believe, output is 16 or higher. So it's greater or equal 16. Then we want to print grade 16 plus. Otherwise, we want to print grade and our result formatted here. So it's a result underscore index. Okay. So let's make our program once again. Let's clear the terminal. Let's make our program once again. Oh, I forgot the semicolon as always. Okay, so now our program should output before grade 1. Yep. So that's great. I think we can use a new line character here just for the readability purpose. Let's make sure that it's working before grade 1. Okay. So we can check whether our program is correct by using check 50. Let's check it. We need to wait a bit. Okay. We want to see more detailed result for sure. Okay. So looks like it's working just fine. And we can submit it. But before submitting it, we have to check our style. Because I'm used to more to the JavaScript, not C. So I might have messed up a bit of formatting in our code. So let's use the handy tool here. So let's apply changes. Yeah, those changes are only related to the formatting of the code. So let's apply them. Now our code looks really good. Let's make sure that it looks good. Okay, and let's submit it once and for all. Okay, so let's see the result here. There we go. We have maximum points for style and for tests. And we submitted it. So I think that's all for today. We covered a lot and we were able to solve this readability issue, which is the second issue in the arrays problem set. Yes, exactly. And the next one will be Caesar and substitution. But other than that, I think that also Scrabble addition at the beginning was quite useful to make sure that our program is more bulletproof. And thanks for watching and see you next time. Bye bye.